Determine whether the given relation is an implicit solution to the given differential equation. Okay, so the difference between this problem and the first two problems that we did in the previous video is that here y is not given as an explicit function of x. In fact, it's impossible to write this equation as an explicit function of y. There's no way to separate x and y because of these two terms. And we still need the derivative of y in order to check whether this is a solution or not. So what we do is we use implicit differentiation, which we did learn in Calc 1. And we have this expression and we have to find dy over dx out of it. So let's just do it. So I've rewritten the expression here. And if you remember from Calc 1, the way we do implicit differentiation is we just keep differentiating everything that we see. And wherever we encounter x, the derivative is 1. And for y, the derivative is either dy by dx, or in shorthand, we can write it as y prime. So let's do it. So the derivative of e power xy is e power xy. And then by the chain rule, we need the derivative of xy, which will be by product rule 1 times y. The derivative of x is 1, and we keep the y. And then plus, now we keep the x, and we take the derivative of y, which is y prime. Plus, so this all was the derivative of e to the xy, and then plus the derivative of y will be y prime equals, on the right hand side I have x, the derivative of x is 1, and the derivative of 4 is 0. And then we can distribute this. So this will be y exy plus xy prime exy plus y prime equals 1. And then if you remember from Calc 1, the next step is to isolate y prime. So these two terms have y prime. So I'm factoring out a y prime from them. And I'm left with x exy from the first term and plus 1 from the second term. And then on the right side I have 1, and also I move this term on the right because it doesn't have a y prime. So I have y prime terms on one side and then non-y prime terms on the other. And so y prime comes out to be 1 minus y exy over x exy plus 1. Let's write it over there. 1 minus y exy y, oh no, not this. Y, okay, let's go see it again. 1 minus y exy is the numerator. And the denominator is x exy plus 1. Okay. Applying implicit differentiation to the equation gives Okay, they didn't say that gives the derivative as this, but that's what they mean. Okay. So now let's see. We got y prime is equal to this, and the equation is saying y prime is equal to this. Now at first sight, they don't look the same, but let's examine them more deeply. So yeah, they don't look the same at all. But let's not hurry up. So you have negative y(e)(xy). So look, over here, the powers are negative and my powers are positive. So what if I, in order to see whether this is the same as no, so although they look different, but they well be the same. They may well be the same. So in order to make the powers positive, you can multiply this one by e to the xy, multiply every term with e to the xy. So when I do e to the negative xy times e to the xy, I get a 1, which I do have here. And then I multiply this by e to the xy, I get negative y(e)(xy, which is what I have here. And then multiply this term by e to the xy. So I get a 1, e to the negative xy times e to the xy is a 1, which is this. And then this times e to the xy is xy. So they are the same actually, because you're always allowed to multiply and divide a fraction by the same quantity. And in this case, we chose the quantity e to the xy to multiply the numerator and denominator. That doesn't change the fraction. So this one is equivalent to the given, and therefore this is a solution. Let's see. Which is equivalent to... what's wrong here? Everything seems fine. Let's look at the typesetting. So do they mean dy? Do we also have to write dy by dx over here? Yeah, I think so. So this was y prime or dy by dx. So now it should work. Yeah. Okay. Determine for which values of m the function phi x equals x power m is a solution to the given equation. So let's see. So first of all, what we do is you replace y by x to the m. So phi of x, we're wanting this to be a solution. So that's a y. So it's just like if you have f of x, that means y here. They're writing phi of x, so that's a y. So if y is x to the m, then we have 2x squared. And now this is the second derivative. So now the first derivative is m times mx m minus 1. The second derivative will be m minus 1 x to the m minus 2. And then you have minus x times the first derivative, and the first derivative was m times x power m minus 1. And then you have a plus y, and y was x to the m. So we can see from here also, remember the mxm minus 1 was the first derivative, And when you take the derivative of mx m minus 1, you get m times m minus 1 x to the m minus 2. So that's why that was the second derivative. So now let's see what this simplifies to. That's equal to 0. And we have to find the value of m so that this holds. So now if you simplify this, you get m minus 1, and this one simplifies to, so x squared and x to the m minus 2. So when you combine the powers, you add the powers when they are being multiplied. So 2 plus m minus 2 would be just m. The negative 2 and the plus 2 cancel out. So you just get x power m here. So let's simplify it right here. This simplifies to x power m when it combines with this x squared. So this one goes away. Okay, so we have 2m, m minus 1 x to the m, and then we have minus xm. So we have x, this is x power 1, and this is x power m minus 1. So here again, when the 1 gets added to the m minus 1, you just get an m. So this x goes away. And this becomes an m when we simplify. And here I already have an m. So now all these terms have an x power m. So if you factor out an x power m, let's see what we get. So if I factor out an x power m, so let's put a comma here. X power m is factored. I am left with, so here I can distribute the 2m with the m minus 1, so I get 2m squared minus 2m. And that's what I get from here. Then here I get a negative m. And here I get a plus 1. Remember, I'm factoring out an x power m. Okay, is equal to 0. Can even erase this one. So now you know that an exponential function is never 0. So it's this part which needs to be 0. So I can erase all the other things. So x to the m is not 0. So the other part is 0. And now this is 2m squared minus m plus 1. Minus 3m plus 1. These two combine to negative 3m. And now let's see how this factors. This factors into, is it 2m minus 1 and m minus 1? And from here I get m, this one gives me m equals a half, and this one gives me m equals 1. So there are two values of m equals a half and m equals 1. So oh, I need to put a comma. I think I put a period. Okay. And then you do the exact same business in this equation, and I leave that for you. And that finishes the section.